So, good morning, everyone, and thanks for coming to our show here. This is Jeff Martin, my co-speaker. Why don't you say something about yourself, Jeff?
Hello. I've been programming Java for 25 years now. Started at Apple and I have my own little software company and moved to Java.
So I'm Kai Horstmann. My claim to fame is having written a Java book 30 years ago. It's now in its 14th edition. And so we're going to be distributing the work here. Jeff is the expert in doing all things with Java in the browser. I know a little bit about using WebAssembly on the server. So that's how we're going to do it. What you see here, by the way, is a nifty application that runs Java in the browser. That shows a markdown as a presentation. So we're eating our own dog food here. This is something that Jeff has put together. All right, so let's go through a few concepts. But before doing that, so you all know that WebAssembly is a bytecode format. It runs a virtual machine. That's not the same thing as the Java virtual machine. It's its own thing. We'll talk more about it. It runs in every browser, and so today you can't see it in the wild. There's popular applications from Google, from Adobe. Microsoft has a whole toolkit for building user interfaces that get deployed through Wasm. I'll show a couple of demos here for a few seconds each. Here we see you can run SQL in the browser. So SQLite was implemented in WebAssembly. And so now you can do your SQLite queries, like if you wanted to teach it, for example. Here we have a little application, that runs Pandoc. That's a document conversion format. You could upload like a Word file and convert it to TeX or whatever conversion you want to do. And it's all in the browser. That means that that document is never processed somewhere in the cloud, so it could have confidential information in it, for example. It's a nifty little application, and we'll actually come back to this application a little bit later. What if you wanted to do some Python programming, but you don't want to actually install Python on your computer? This thing here runs Python in the browser. You can type some Python code here, and then you can execute it. And so like if you wanted to run some activity with students and you can't rely that they install anything, here you have it. So running stuff in the browser is a perfectly good use case. Now, we kind of had Java in the browser at one point, and so it's very different from Wasm. So in Java, what ran in the browser is a Java virtual machine. It does objects, it does garbage collection. It, of course, interfaces with the world. So it can paint pixels, it can make network connections, and so on. And as we know, I know because I was around when applets were a thing. You may not remember. It takes a while to get all of that started. Wasm, on the other hand, is a much simpler virtual machine, and it starts up very fast. And it does not have any system access at all. So let's see, why do we then care about having Wasm instead of Java as a virtual machine? Well, of course, because Wasm does run in the browser, whereas, as we know, Java no longer does, sadly, right? And also, we can do things outside the browser, as we'll see in the third part of this presentation. One can compile all sorts of languages into Wasm. So, for example, JavaScript, Rust, Go, and C++. And then when they're in Wasm, you could call them from Java. And conversely, you can compile Java into Wasm, and then you can have your Wasm, your Java code that has now been compiled into Wasm executed in certain environments. So there are two big use cases that we'll be looking at in this presentation. The first one is Java, again, in the browser through the power of Wasm. That is Jeff's thing. And so you could use it, for example, if you have a web application. And if you don't love React, you could actually use your Java skills to write a user interface in that and then deploy it in the browser like that. Or you could, and you'll see some fantastic apps that Jeff has produced, you can run all sorts of things in the browser that don't have any backend. They just run in the browser, just like applets used to do. The other use case outside the browser is, and that splits up into two sub-use cases. We can have Java calling Wasm Now, why might you want to do that? Of course, you could just use foreign functions, but we'll talk about why you might want to do that. And conversely, you can compile Java code into Wasm, and then you can run it in certain environments that can execute arbitrary Wasm. And of course, if they can execute arbitrary Wasm, wouldn't you want to author it in Java instead of some of those other inferior languages? So one of the things that I think when we need to wrap our head around is that Wasm is super limited. So we're used to the Java virtual machine, which is very rich. And so the Wasm virtual machine, it has variables, it has gotos, it has arithmetic, it has a notion of linear memory, so you have a block of memory containing bytes, and everything else you need to do by calling out to some external services. So there's nothing there to paint pixels or anything, or to connect to a socket. The only mechanism they have is a call out that you then have to supply somewhere else. We'll see many examples of that in the third part of the talk. So, people say that Wasm is very safe because you can sandbox it, and it really can't escape much out of the virtual machine. And that's, of course, because it can't do anything. Contrast that with Java. Why don't we have Java applets? Because Java can do all sorts of things, and the attack surface was so large in the end that people came up with nefarious attacks where they did serialization trickeries and things. And there's just so much going on in the Java virtual machine and in the large class library that is attached to it that at some point Oracle just said, we can no longer guarantee security of this. The browser vendor said, we're taking it out of the browsers and so on. So Wasm is the other side of the spectrum where the security of Wasm is because it can do so little. And then that's easy to sandbox. So that does mean that you need some kind of glue code to interact with Wasm. The glue code doesn't strictly have to be in JavaScript, but in all of the examples that we will see today, it is in JavaScript. So anytime that you want to transfer something into Wasm, you need to get it in some other shape, shuffle it into the memory blocks. Conversely, when you call out of Wasm into something else, there's usually some bridge code that's written in JavaScript. And that glue code can be substantial, and it can be non-trivial to produce. Keep that in mind when we look at it a little later. So a couple of buzzwords that will pop up. There's a thing called, and they all have cute names. So there's what? That is the WebAssembly text format. We will not actually see this today. I've put in these links in case you later want to download the slides and dig a little bit deeper. That's the same thing as the WebAssembly binary instructions, but just written in text. There is a thing called Wabbit that has tools. For example, Wasm to what will take your Wasm file and turn it into that text file format. And it has a bunch of other tools in there that we sometimes need. More importantly, there is the WASI, the WebAssembly systems interface, where I told you before, there's no way inside Wasm to actually read a file or connect to a socket. And those things are now being specified and standardized in the WASI effort. So there are so-called WebAssembly components, mercifully not WAC, that standardize a component model. And the most important part of that is an interface type description. So if you wanted to come up with some other way of calling from the Wasm that does nothing into the world, then one can describe that with these interface types. Of course, all of the things that are in WASI are being so described. And it's important to know that this is all very bleeding edge. So if we look at this Wasm web page, you see that there is all sorts of features and different runtimes support them to various degrees. And so in practice, when you want to work with this today, that is something one needs to know about. The WASI itself also, when we go there, we'll see that it too comes in phases. So there's a 0.3, 0.2, and every tool that we'll be showing you today is at a different level of these things. And it makes, so today the kind of interoperability that eventually will be there is still a bit of a struggle. All right, so I'll turn it over to Jeff, and he's going to talk about the browser.
Yeah, so there actually, if you know where to look, there's probably a dozen or more solutions of getting Java to the browser, starting probably 15 years ago. GWT was one of the big ones, and I think Google was the champion of that, but they've kind of morphed that into something called J2CL. And of course, a lot of the Google Docs apps use it still. The big problem with it for us that love the pure Java is that they don't support the standard runtime. So we've limited, for the browser section here, we've limited to 3 contenders that really seem to be care about what we care about with the runtime. There's CheerpJ is an actual JVM in the browser, and then so I call it the reigning champ because it's the closest to what we're used to on the desktop. And TeaVM is the real scrapper that's been around for a while. There's one guy that works on this, and it's a really amazing feat of engineering. Where he takes your Java bytecode and turns it into JavaScript or WebAssembly or even C, and does a minimization. Actually, let me progress to my slides here about. Of course, so CheerpJ, like I said, is the full JVM. They took the OpenJDK and actually did a port, and then they're just on the back end, implementing like the platform services that we expect. And so it actually just takes takes your actual jar file and you put a little wrapper around it, and it pulls in your jar file, pulls in the JVM, and it's really clever about it. It uses byte ranges, so it doesn't pull in the 80 megabyte runtime file. It might only pull in 10 megabytes of it for most applications. And then TeaVM, like I said, is it takes a different approach, is ahead of time. So it takes your bytecode and turns it into WebAssembly. So you don't have to have the just-in-time overhead. And then they can also, TeaVM does this amazing job of minimization. It finds all the dead code. It only pulls in the parts of the runtime that you need. And then it does minimization as far as all the symbols to get that file as small as possible. And then we have this new contender, GraalVM Web Image. And they're really taking the same approach as TeaVM, but they're using the actual Java runtime. And so it will probably be a really good contender and a lot more bulletproof as far as getting consistency. What runs on the desktop runs the same way in the browser. So my hands-on here is compilers. For some reason, whenever somebody has one of these tools, the first thing they want to do is compile Java in the browser. And so every one of these tools has an example. And so here's our Java code in the browser. And you've probably seen a lot of tools like Java Playground that you can type in Java code. And what they're all doing is a round trip to the server. So they're sending it out to the server, it's doing the compile, and then it's sending the results back. Or in some cases, they'll run it and send just the run back. And but this is actually pulling in pulls in the whole compiler and compiles it in the browser or in the client. So you don't actually need a server for this other than a static website. And I think I got my run there. And I'll just show one other. The GraalVM is very similar to the TeaVM. I guess they're all very similar. What's that?
Zoom in the browser. Zoom in.
Oh. You know, actually, I don't even really know how to do that. Is it just? Zoom. Okay. Yeah. Yeah, thanks for that. Okay, so that's the compilers. So of course there's just some undeniable benefits. So my little company ships apps, and you want to get apps into people's hands. And these days that's a little scary. You go to some site and there's an app and it sounds promising, and you think, well, I download and install this. Do I trust these people? Is it going to download 100 files and hide things, squirrel things away that I'll be carrying with me for the next 20 years? So it's really nice as far as getting rid of barrier to entry to have something in the browser. And then you don't have to worry about the security concerns. Code signing was an issue. For a long time, I was chasing this with desktop apps where I write the app and I have to get it, you have to code sign it, and that's jumping through a lot of hoops. And you get real run anywhere. If you get it running in the browser, it runs on a tablet, runs on a phone, runs on a laptop. A lot of cars will run on their console. And then you get a great, in the Java ecosystem, you get just the best of class running on the desktop. You'll hear JavaScript people complain all the time about they take their app to the desktop and they run it in Electron and it's immediately a gigabyte Chrome-wrapped application. But of course, there's some downsides that Wasm, as Kay said, it's really designed to be as simple as possible and have as little as possible. And of course, they're incrementally adding all the pieces we need. But right off the bat, we don't have a file system in some of these tools, and then the ones that do support Java file systems have emulated it, and they'll save it to like IndexedDB. So it's local, so you can't get access to files on your desktop without adding an interface for that. But there's ways around all that. Networking is an issue in the Java world. We're used to saying, give me this HTTP URL and getting the bytes. The browser is not that way. It'll complain unless the target website is configured to allow it. But there's ways around that. There's VPN type solutions, or there's CORS proxy where you can take the URL and send it out to a backend server that fetches it and gets the bytes and gives it back. But it is an issue. When you're developing, backtraces can be problematic. These tools all will try to minify, so when you get a backtrace, it won't say the methods you're used to. You'll see little encoded strings in there. And transpiling can be time-consuming. We don't have this problem with CheerpJ because it's actually running the jar file out of the browser. But the other tools, after you get your bytecode or your jar file in the shape you want it, you kick off the transpiler, and it might be 20 or 30 second iteration. And Java, one of the great things about Java, I think, is our development is so quick to iterate sometimes. And you lose a little bit of that if you're really iterating with the browser. So let me show snap code here. So this is a pretty good complete application. So first, just going to the website. So Snapcode is a Java IDE, and a lot of times when people are getting started, there's how do I get started with NetBeans or Eclipse or IntelliJ, and there's a 5-page instruction manual on how to get started. And in the browser world, we just say run it. So just going to the website where we're reading the materials, I can just hit playground. And so this differs from the Java playground in that there's no server. This is all static. It's all running on the client side. And it, we can type in our code here, and it's already done a compile for us. And when I hit run, it'll run, and it's running in the browser. And this is a good example of a hybrid application where we've got Java and HTML and JavaScript, and then we've got Java client UI in the same page.
Oh, Jeff, I didn't get that. That button there?
Uh-huh.
Is that swing, or what is the button?
Well, so it's on top of Swing. Snapcode is written using my own Java UI kit. And the benefit of having a custom UI kit is that it can run on the desktop. It uses Swing and the graphics 2D object to render all the pixels. And in the browser, it can actually use the HTML canvas element and use the DOM APIs or the web APIs to get full native speed in the browser. And it doesn't have to, download all of Swing's imaging libraries and such like that. So that is an option, and then we'll talk about DOM programming in a moment here. And I'll go ahead and hit run out from that same page, and it brings up the whole browser, the whole application. Hopefully, except for my UI aesthetics are not so good, but it can definitely look just like a real web application. And you notice like the launch time. In fact, I'm going to be brave here and hit refresh. And so it's launched the program. Now, the first time you do that, it pulls down 15 megabytes of runtime. But that's really not that much anymore. You go to NewYorkTimes.com and it's 49 megabyte download, according to a blog I just saw. So 15 megabytes, that's 2 seconds of YouTube video. So a lot of people won't consider Java in the browser because they think, oh, it's prohibitive to run the application. But really, 1 second launch time, it often launches faster in the browser for me than it does on the desktop. So I'll just say new Java snippet, and I can just start coding here. And so this tries to have all the modern features that a normal IDE has. But it should be a lot more approachable. Education often has a problem where they don't have desktops anymore. They've got Chromebooks, and so they can't install on the computers they've got. So the ability to be able to bring up a full IDE in the browser, you don't waste a day doing the install. And we get full sophisticated applications. So I'll just run through a couple of quick things here. This is like doing a turtle graphics that, let's see, find my source file again. Yeah, so I add the code for this turtle graphics here. And I add the code, it does a compile behind the scenes for us, and it's running inside of there. And then this is something we see a lot with Python now, that gives me a little bit of Python envy. Students can go into their Python and they can just type in a little bit of a few lines of code and get some graphs up. And so now we can do that in Java. And so this is actually showing off WebGL bindings. And so this exact same program runs on the desktop. And that's where all the development is. And so the development's super easy. When it gets to a state that I want to do a ship, I just take the exact same jar and put it on the web, and it's done. And I am quickly running out of time here. As Kay warned me I would. Let's see. So let me show a quick DOM demo. So when you want to talk to, if you want a lower level than something like Swing or SnapKit, DOM, all the tools, the Graal and the Chirp and TeaVM let you call out to the DOM APIs. And so here we just say, give me a window document. This will be familiar to anybody who's done JavaScript in the browser. And create a button and show the button. And so this will be a little underwhelming because the button looks like any other button.
I'm always terrible with this. This is a Swing button?
Yeah. Oh no, this is HTML, and so we have so much stuff going on. We've got the CheerpJ JVM running. We've got SnapKit on top of that. We've got the compiler pulled in, and then we've got a child process, and the child process is an iframe, and the iframe's got an HTML document, and inside of there we've got our HTML button. All
right.
Okay, and let me just go back to the slides real quick. So here's the DOM programming we talked about, and we talked about the Java bridge. We can generally get straight to the web PIs with a bridge library, but there's also ways to just execute raw JavaScript strings. I just got a few slides here about getting started. All these things are super easy. You just basically have a process that says turn my jar file into bytecode or into WebAssembly, and you wrap it in a little 10-line HTML file, and it'll run. Same thing with Graal. So in the slides, you'll see this. There's a pointer to the guide, and the guides are in general just 1 page long. And with that, let me go back to Kay for hands-on the other direction.
Yeah. So I need to switch laptops because I'm actually going to be running a few things here. So now we're back on the server. So you've seen that in the browser. This is pretty fantastic, right? You can run Java in the browser better than it has ever worked before. You can write user interfaces in Java without having to use that other inferior language that so far has been used for writing in the browser. So lots of things can be done, pretty elegantly, and the technology really shines there. Now let's get outside the browser. So what is possible, and I'll show you a couple of ways of doing that. You can take any Wasm code, whether it originated from Rust or Go or C++ or whatever, and you can call it from Java. And so why might you want to do that? Of course, you can call C++ code from, well, you can call C code from Java, right, with foreign functions or with good old JNI. If you wanted to call Rust code from Java, that's not so easy. So now you can, though, do that if you first compile it to Wasm. So one reason some people do this is because of the sandboxing. They have some foreign code. So I actually talked to someone who says they get code from a customer that does some business logic. They don't really trust it. They put it in a Wasm sandbox so that they can run it inside their Java application. So there's a few of these runtimes that enable this. One of them is called Chicory. It's written in Java, and so it runs Wasm. That means you can call it from Java, and we'll see in a minute actually an application that does just that. It's kind of limited. It runs a WASI at the 0.1 level. It doesn't have any support for exception handling, so that's a little icky. There's GraalWasm. So with Graal, we have to be careful. So you showed us GraalWebImage. So GraalWebImage will turn Java into JavaScript or Wasm that can be run in the browser. GraalWasm will turn things, will make it so that you can call Wasm from Java, that you can consume Wasm from Java. Then there's GraalJS, which lets us consume JavaScript from Java, and they're slightly different. We'll actually be seeing GraalJS in just a minute. So let's just.
So Graal does both sides of our presentation.
Yes, Graal is super confusing in that it can consume Wasm and it can produce Wasm, and they have slightly different code names for each of those things. So yeah, keep slowing me down whenever I'm too fast for that. All right, so let's run one demo. So just a few days ago, I saw, Chicory is now available as a Quarkus extension. And I said, hey, so let's just make something with Quarkus and Chicory. And so what I did is a thing that converts Markdown to HTML that is being called from a web application. So this code now, unlike all of the things that Jeff has shown, will run on the server. So let me run this really quick. So, terminal. So I'll just start it up and go to localhost 8080 and we'll see when it comes. It'll be there in just a second. Here we go. So here, we have Markdown input on the left. If I type convert, then on the server, it will now have called this WebAssembly module and converted the markdown to HTML and put it in an iframe. All of this happens on the server. You might say, well, what's with that? And I'm just using this as a proxy for there is this conversion library. Someone has written it. It exists in Wasm. I don't want to rewrite it. I'm just going to call it from Graal. So the code is, let's have a really short look at that. Is actually super simple. So over here you see some standard Quarkus stuff where we're just calling some method, and that method is then implemented here. So it calls by using the Graal bridge. It calls into the Wasm module, and the thing is not super confusing, except there is a little weirdness down here where you're seeing a callback where it does some memory allocation that, so I, as the user of this, have to supply little snippets of code that do odd things, like allocating some block of memory. And so how do I know that? I had no idea. So of course I asked ChatGPT, and it did a very good job to give me these little pieces of random looking glue code. I mean, one can figure it out, and it's tedious and time consuming to do it. It's just something that when you have a project like that, you think that you have this module that you can just call. There is a bit of work ahead of you. And so the next thing that I tried is I said, well, this markdown to HTML, I mean, that's small beer. You can, of course, do that in Java. Let's take something more complicated like pandoc. Pandoc is written in Haskell. Obviously, it would not be all that easy to call it from Java. You could call it in a separate process, but you can't just call it directly and sandbox it. So having that Wasm module of pandoc, I thought that's great. So I talked to the Graal people and say, well, what would it take to run pandoc inside Graal? And so they made me a demo because I couldn't do it. I'm not going to run it in the interest of time, but we'll have a quick look at the code. So we see a tantalizing looking pandoc Wasm library in here. That is actually not the Wasm library that I downloaded from the site that I showed at the very beginning of the presentation, because that library uses a version of exception handling that Graal cannot take. But the guy from Graal said, not a problem. We're going to run it through one of these tools, and that'll rewrite the entire module to use a different style of exception handling that does work with the current version of Graal. And then I thought, oh, I just call, because when you use it in JavaScript, you just call one JavaScript function and it does the conversion. Okay, I was prepared that I might have to figure out how to get the string into bits and into a byte array and conversely out again. But it turns out one has to do a lot more. So they wrote me a bunch of glue code, which we see here, that in JavaScript that loads this module. And I was going to show you so that you have an idea, of the extent of what that thing is. So that's kind of a pain that one has to do. Sorry, this is a shell script that generates this. The glue code is not that bad. Let me pull it up. Here it is.
So even when passing strings back and forth?
Oh, you have to put them into memory. Yeah. So the string you have to then convert into byte array, and then you have to use whatever mechanism this particular configuration needs to put that into. Then you have to make the memory allocated, give a pointer to that thing to Wasm. That's the way it works. So Wasm really knows nothing but numbers and pointers inside byte arrays. So these pointers are safer than C pointers in that they are tied to you can't overrun the block, so that's why you have safety. But you do have to do that transformation somewhere. And so what one wishes, of course, is, and that is the promise, that at some point these type definitions that are going to be coming, that they can be transparently then proxied in Java. We're not there today. So today there is this glue code that you have to do, but no, this promise is definitely there. All right, so here, like I said, we see some of this glue code, and so I asked my friend there at Graal and said, how did you write this? And he said, the chatbots are pretty good at it. And so it's just something to know about. All right, so we can run a Wasm module inside a web app with a bit of magic. And so you would do that if for whatever reason you have this module that does some functionality and you don't have it in Java, but you have it in some other language, you compile it down to Wasm. There's another nice example that the Graal people give where they have an image processing library that was written in Rust, compiled down to Wasm. They call it and do some image processing on the server. And so if you have that kind of use case or contemplate having it, that is an option. All right. The other thing that one can do is you can compile Java to Wasm and then run it. How would you run it? Well, there's some systems that will run it. And I guess first I should say, how do you even compile from Java to Wasm? There's two ways. One is with Graal, and the other is with TeaVM. There's a couple of others that, I mean, I've tried them. They kind of work, but they seem to be more or less either a single person who does it or kind of abandoned. So I think really Graal and TeaVM are where you can use it. So you can deploy it in Cloudflare. Cloudflare has like Wasm workers. You could deploy it there. You could deploy it with a thing called Fermion, which was bought by Akamai. And so it'll run a Wasm module on that Akamai network. And so they say it's a great thing, it's sandboxed, it's fast startup, which it really is, it's low resource usage, and wouldn't you want to be able to write these services in Java? There's an API that supports Rust and Python very nicely, but it doesn't really do anything great with Java. What you can do is you can run your Java program just like you used to run a Perl program in CGI. So you feed things into standard input, you read from standard output, and you make you give the call parameters through an environment variable. So as long as one can read standard input, write standard output, and read environment variables, you're good. So of course I had to try that, and I said, well, what can I do at the edge? Well, there is a need for a service that gives you a random joke. And so in order to have another parameter, I also have like a random quote. And so I deployed this now to the Akamai network, and anywhere you can now have this at a node near you. So what did I have to do? I wrote the thing in Java, used TeaVM to convert it, because for some reason Graal is not today ready to produce the kind of Wasm that Fermion wants. They will at one point be ready for that. All right, so one needed to, again, overcome some limitations that ChatGPT helped me out with, where I had to bridge, and in the interest of time, I'm not going to show it now, but you can download all of that code, and it's kind of interesting to read through if you actually have to do something like that, where you can make a bridge so that I can read an environment variable. And so now I can read an environment variable, and I can go and get my random joke. Let's see if I find it here. Oh, no, sorry. I'll just run it locally. It's not worth it. The jokes are no good. Localhost.
But they're better in Java.
Yes. Okay. All right. Well, here you go. I told you it's not worth it. All right. So, so in summary, where are we at? So on the browser, things are good, right? Absolutely. So I think we all agree. In the browser, things are good. On the server, we have these two separate use cases. Java can call Wasm, or one can compile Java into Wasm so that it can be called. And both of them, kind of work. There's tools that make this possible, but there really are challenges. So right now, the interface between your Java code and the rest of the world is super clunky. And it can get better, but it's not there today. The API access is by design limited, so the tools that we want will need to work on making that much more transparent. It is not reasonable for a Java programmer to have to worry about how to do that. Right now, there's a lot of incompatibility between the tools. which versions of Wasm and WASI they support, and also when you pick up a module in the wild on how it was produced. And so there's some bridging one has to do about that. So is it the future? Well, Charles de Gaulle famously said about Brazil, Brazil is the country of the future, and it always will be. And depending on how you read it, right, he was a diplomat, this could be a positive statement. You know, once that it has achieved its promise, it will always stay there. Or you could read it in a way that, you know, saying, good luck. And so that is
Part
something.
of what we're trying to do is evangelize, right?
Yeah.
It's not that it's too hard to make this work, but it's a chicken and the egg situation of where's the user demand, where's the developer demand.
Yeah, so this could be great, like Brazil. So all the pieces are kind of coming together. They're not coming together right now. So when you read a blog, you know, read through the blog carefully and see whether what the blog describes is actually working today, whether the working is with a bunch of baling wire and duct tape, or whether it's not working at all. I did read one blog where they claimed to run an arbitrary Spring Boot application on the edge in Fermyon, and it simply is not possible to do that. They claim to have first translated to x86 instructions, and then from x86 instructions to Wasm. This is simply not a thing that one can do. And upon further inspection, it was, of course, an AI-generated blog. So be very careful what you read about. So I hope we gave you a few ideas on how to do reality checks on what you do read. So browser, A-OK, server, work in progress. Questions?
So, well, first, a word of advice. There are quite a few Brazilians at this conference.
Yes. Yes, I told Bruno to put them all in another room somewhere.
But, so, how compatible across browsers is Wasm?
Extremely compatible. I mean, a lot of them are using the same V8 engine. You know, so Edge and Chrome, and I think Safari, if they're not using it, I think they announced they plan to. But it's been really consistent. Things that work on Firefox and Chrome, I try to test my apps, and so far I've had no real issues.
Other questions? Okay, well, if you have more questions, you know where to find us in the hallway. And if you have any actual use cases or anything that where you know more than we do, you know, seek us out, and we'd be glad to chat. Thank you.
Thank you.